All right, so we're going to look at types of discontinuity. Now, we have a lot of problems to get through today, so I'm going to go kind of quickly. If you find that I'm moving too fast for you, just pause the video and kind of catch up. But I want to try and make the video as short as possible while also getting through everything. So, discontinuity. Okay, so discontinuities are breaks in my graphs. Okay. And there are three main types of discontinuities we're going to talk about today. The first one being removable discontinuities. So removable discontinuities are the holes in my graph. So those are the open dots, things like that. Okay. Now, we get holes in our graph when we cancel factors from the denominator and the numerator. Okay, so I want to make sure I have my top and bottom of my rational function factored as completely as possible, and then if something cancels out, that's where the removable hole comes from. So looking at number one, we're going to start by factoring everything. So factoring the top, factors of 6 that add up to 5, I would get x plus 3, x plus 2. The denominator, factors of negative 15 that add up to negative 2, I would get x minus 5 and x plus 3. Now, I notice that I have an x plus 3 on top and bottom, so that is where things cancel. Okay, so that's where that removable discontinuity is going to come from. So my new function after I simplify is going to be x plus 2 over x minus 5. So I need to figure out the ordered pair where that hole is going to be, okay? And I get the x from the factor that cancels. So I have this x plus 3 here. So if I set that equal to 0, I get negative 3. Now, I'm going to take that and plug that x in to the simplified function, okay? Don't plug it back into the original. So plugging negative 3 in, I get negative 3 plus 2 on top, negative 3 minus 5 on the bottom. So we get negative 1 over negative 8, which is 1/8. So I would describe this discontinuity as a removable discontinuity, right, a hole, at the ordered pair negative 3, 1/8. Okay. Now, number two, we have some different type of factoring we need to talk about. Right on top, you notice that we have perfect cubes. So I put the difference of cubes up here in case we forgot. Remember, it's the same process for sum of cubes. It's just with sum of cubes, you'd have the plus sign in the middle. But we had those acronyms to kind of help us remember how to do this. SMS helped us get the terms. So square the first term, multiply the two together, square the last term. And then SOAP, same opposite, always positive, to get the signs in between my terms. So my A would be x, my B would be 5. So SMS, square, multiply, square, and then SOAP, same sign, opposite sign, always positive. So there's the top. On the bottom, I have difference of squares, right? So A would be x, B would be 5, and I would have x plus 5, x minus 5. Now, I see that I have an x minus 5 on top and bottom, so that's what cancels. And my new function is x squared plus 5x plus 25 all over x plus 5. Now again, I have some stuff canceling, so I need to find that ordered pair where my hole is going to be, where that removable discontinuity is going to be. So looking at what canceled, that's going to give me x equals 5. So plugging that thing in to my simplified function, get 5 squared plus 5 times 5 plus 25 all over 5 plus 5. So we get 25 plus 25 plus 25. So I'd have 75 over 10, which would simplify down to 15 over 2, right? Dividing top and bottom by 5. So my answer, I have a removable discontinuity at the ordered pair, 5, 15 over 2. Okay. All right, last one here. I need to factor the top and bottom, but we notice that on top, I have an a value that's not 1. So I'll show the AC method here real quick in case we forgot. So a times c would be -6, and my factors need to add up to -5. So that gives me -6 and 1. Now I'm going to set that up to do grouping. So we would have 3x squared minus 6x plus 1x minus 2. Do my grouping. And I see that I could take a 3x out of the first two terms. And a +1 out of the last two terms. So my two factors would be 3x plus 1, x minus 2. So that's the new top, right? The new numerator. On bottom, I need factors of -2 that add up to -1. So that would be x minus 2, x plus 1. Cancel what can cancel. So I have an x minus 2 and an x minus 2. So my new function, 3x plus 1 over x plus 1. Now, looking at what cancels, right? That tells me that my whole is going to have an x value of +2. Plugging that thing in, I get 7 over 3. So I would have a removable at 2, 7 over 3. Okay? So that's dealing with holes, my removable discontinuities. Now we're going to look at a jump. Okay, and we've dealt with jumps before when we dealt with piecewise functions, right? It's where the graph physically jumps up or down. Okay? So looking at a graph, right, I see that I jump from here to here. So we would describe this discontinuity as a jump at x equals -2. So that's how we describe jumps, okay? Now, when we're not given a graph, we have to figure out if my piecewise does have jump, okay? And the way we do that is by looking at my change value. So if I think about, here's 2. So the top equation, x is greater than 2. So that means x plus 4 is going to be over here. X less than or equal to 2 on the bottom, right? So 2x minus 3 would be on the left side. Now, what I'm doing, I'm going to plug that 2 into both equations. If they are not the same number, once I evaluate it, then we say we have a jump. If they are the same, that means that they have the same y value when I plug in that x, so it would be continuous. So let's look at an example of them being discontinuous. So let's plug in 2. So 2 times 2 minus 3 leaves me with 1. Plugging in 2 on the right side, right, so the top equation, 2 plus 4 gives me 6. Now, since the two sides are not the same, we have a jump. X equals 2. Now let's look at what happens when they are the same. So, -1, top equation, x is less than -1, so that's the left side. So x squared minus 2 is over here. X is greater than or equal to -1, right side, so 3x plus 2. Now let's plug in -1 and see what we get. It would be 1 minus 2, which gives me -1. -3 plus 2 gives me -1. So since the two sides are the same, this would be continuous. And what's happening here is, on the left side, I have a quadratic with an open dot, right? On the right side, I have a line with a closed dot inside of my open dot. So there's no jump. The two functions start at the same place, right? Okay, now, infinite discontinuities is where things get a little bit crazier. So, infinite discontinuities are my asymptotes. So we can have three types of asymptotes. We can have vertical, horizontal, and slant or oblique. And all of these are found in a different way. So we're going to kind of break this down and look at each one separately. So vertical asymptotes. Okay, vertical asymptotes come from my denominator equaling 0. Okay, now the steps we're going to take to find vertical asymptotes. Factor everything. Okay, that's always going to be our first step for all of these types of problems. We're always going to start by factoring. Once we factor, I'm going to cancel anything that I can get to cancel. Okay, so look for those removable discontinuities first. Then, if I have anything left in my denominator, that's where the vertical asymptotes come from. So, looking at number 1, okay, make sure top and bottom are factored. They are. No removable discontinuities. So I go right into setting my denominator equal to 0. So add the 5 over, and we would have an infinite discontinuity at x equals 5. So we have an infinite discontinuity at x equals 5, and we're going to state that that's going to be a vertical asymptote. Okay. All right. Let's look at number 2. So again, start by factoring everything. So factors of negative 6 that add to 5. That would be x plus 6, x minus 1. On the bottom, factors of negative 2 that add to 1, we would have x plus 2, x minus 1. Now I see I have an x minus 1 on top and bottom. So this is going to have a removable discontinuity, and it's going to have a infinite discontinuity. So we're going to find both. So my new function after I cancel x plus 6, x plus 2. So my denominator equaling 0, okay, that would give me x equals negative 2. So that's going to be my infinite discontinuity. Now we need to figure out my removable. So that's going to give me x equaling 1. Plugging in 1 to the factored function, I would have f of 1, 1 plus 6, 1 plus 2. So I get 7 over 3. So I would describe my discontinuities like this. I would have an infinite at x equals negative 2, and that's going to be a vertical asymptote. And I would have a removable, okay, my whole, at the ordered pair 1, 7/3. Okay. All right, so the last one here, I have difference of cubes and difference of squares. So x and 2 square multiply square. SOAP, same sign, opposite sign, always positive. So there's the top. Bottom, I have difference of squares. So x and 4, x plus 4, x minus 4. Now, sometimes this will happen, right? We'll factor top and bottom, and nothing will cancel out. So now I just need to figure out my vertical asymptotes. So I look at my denominator. I have two binomials I need to set equal to 0. So I would get negative 4 and 4. So I would have infinite at x equals negative 4, which is a vertical asymptote, and x equals 4, which is also a vertical asymptote. Okay. Now let's look at horizontal. So horizontal asymptotes have these three kind of rules, okay? So what we're going to look at is the degree on the top and the bottom. Okay, so my largest exponent on the top, compare it to the largest exponent on the bottom. If the numerator is less than the denominator, so meaning the bottom is bigger. Okay, and again, we're talking about degree, right? So if the bottom degree is bigger, we have a horizontal asymptote at y equals 0. If the degree on top is the same as the degree on bottom, okay, so top equals bottom, then we look at the coefficients. Okay, so the coefficient on the top divided by the coefficient on the bottom. Now, if the degree on top, I'm running out of colors. If the degree on top is bigger than the degree on the bottom, then we either have no horizontal asymptote or a slant asymptote. Now, if the degree on top is 1 bigger, so if the top is 1 bigger, that's when we have a slant. Okay, everything else we would have no horizontal. Okay, and we'll look at examples of all this now. So looking at number 4, again, I want to identify the degree of the top and the degree of the bottom. So looking at 4, I see I have x squared and x to the 4th. So in this case, the bottom has a larger degree, so the bottom is bigger. Whenever the bottom is bigger, we have an infinite at y equals 0. Looking at number 5, x squared and x squared. So they're the same. So now I just want to look at the leading coefficients. So 6 over 2. Over 2, which is 3. We would say that this is a horizontal, sorry. So we have an infinite at y equals 3, which is a horizontal asymptote. All right, number 6. X to the 6th is the biggest on top. X to the 7th is the biggest on bottom. So bottom is bigger. So we would have an infinite discontinuity at y equals 0, which again, horizontal asymptote. Last one here, x to the 3rd and x to the 3rd. So top equals bottom. We're looking at those coefficients again, right? Negative 8 over 2, which is going to be negative 4. So we would have an infinite at y equals negative 4, and that's a horizontal asymptote. Okay, so now let's look at when the degree is 1 larger than, the degree of the top is 1 larger than the degree of the bottom. Okay, so again, this is when the top is 1 degree higher than the bottom. So that's what gives me a slant or oblique asymptote. And the way we're going to find this is we are going to do long or synthetic division. Now, I'm always going to do long division just because that always works, no matter how the problem's set up. If you would like to use synthetic division, you can. Okay, that's another option. But remember, you can only use synthetic division when it's a binomial on the denominator where the a is 1. Okay. So let's look at number 8 here. So I look at my degree and I see that I have x squared on top and x on the bottom, right? So the top is 1 more. So I'm going to do long division. So, to do long division, I'm going to do this one a little bit slower and kind of break it down. I'm going to take the first term on the inside and divide it by the first term on the outside. And that gives me x. So that's what goes up top. Now, I'm going to distribute that x to the two numbers on the outside. So x times x is x squared. X times 1 is 1x. Now, I'm going to go through and change all my signs and do what it says. So minus, minus, those cancel. 4x minus x is 3x. Bring down the next term. And I'm just going to repeat my steps now. So first term on the inside, divide it by first term on the outside. Gives me 3, which goes up top. Distribute that to everything on the outside. So 3 times x is 3x. 3 times 1 is 3. Change your signs. Cancels, and I'm left with 2. So I can't keep going. I can't divide any further, right? Because I don't have an x to divide on the inside anymore. So the thing that's on top, this x plus 3, that is going to be my slant asymptote. So my answer here is we have an infinite discontinuity at y equals x plus 3. And we're going to say that this is a slant asymptote. Okay. All right, let's look at number 9. So, looking at the top and the bottom, I see I'm 1 degree bigger. So let's set up our long division. Now, if I notice the numerator, right, it goes from x squared to 6. Remember, with division, we have to include placeholders of terms that are missing. So I would have x squared plus 0x plus 6. First term divided by first term. So x squared divided by x leaves me with x. Distributing to the outside, I get x squared minus 2x. Change your signs. So minus, plus, 2x, bring down the next term. First term divided by first term leaves me with 2. Distribute, I get 2x minus 4. Change your signs. I get 10, and I can't go any further. So we would have an infinite discontinuity y equals x plus 2. Now, there are 2 more problems here. Go ahead and practice them. Try those on your own. They are on the answer key for the notes in Schoology, so if you want to check your work after you try these, go for it. If you have questions on them, bring them up in class.